Hello, everybody. My name is Lucas, and I'm so excited to share our hackathon project with you all. I want to thank the OpenAI team for sponsoring this amazing hackathon. Our entire team had a ton of fun focused on the intersection of climate change and AI, and we can't wait to share what we came up with. So our team comes from across the world and a wide variety of skill sets, including technical skills, design, and climate change. We wanted to focus on the elephant in the room of climate change, which is renewable energy, and what bottlenecks exist in renewable energy development that GPT-3 can solve. What we came up with was focusing on the financial and policy data that is really hard to navigate and hard to understand that renewable energy developers need before they can get started on a project. In the US, there are 500 plus electric utilities. Each utility has a different utility rate schedule. And these documents are 700-page long in some cases and update every single year. In addition, you have multiple states that release new programs that incentivize renewable energy development. And these are also lengthy PDF documents on a state website that gets updated regularly. So if you're a renewable energy developer, you need to spend a lot of time to really learn about, what are the programs at play? What are the policies at play? And what our product is essentially a search engine for renewable energy developers. So they can pinpoint essential economic and policy data needed to navigate the rules of the land, as well as model the financial projection of the renewable energy project. Focused initially on Illinois and New Jersey, which have new robust statewide incentives, but later expanded to the rest of the country, could greatly reduce the time spent on renewable energy development and make renewable energy developers more efficient. In doing so, we will be the one-stop shop for real-time financial and policy data for renewable energy developers. So the architecture is scraping these lengthy PDF documents from utility and state websites, loading them into a data lake, indexing them because they're so long, and using the embedding endpoint to generate a semantic representation of the source document. Then with the Acropora front end, a user generates a prompt, and we use OpenAI to read from the document where that answer is likely to be contained. And then we complete the prompt using the completion endpoint. Here's a quick representation of how our UI works. You can see answers are generated after a quick filter for geography and topic. And this is in Figma. And now I will move over to our React app where we can see this live. So I'm going to start with Illinois. I'm going to look at statewide incentive programs. And this will look at the Illinois Shines incentive plan. And I'm going to ask, what is the value of a REC produced by a 3.4 megawatt public school solar system? And we can see that the price of a REC is $85.22. This is a really sizable, high value REC price. So this incentive program is really important because it can slash the price of renewable energy projects. And this kind of data is really important for renewable energy developers to get their hands on as quickly as possible so they can push these projects to completion. The impact of this product is improved, democratized access to essential financial and policy data for renewable energy developers, allowing them to quickly extract and distill updates from the complex, hundreds of pages long PDF documents that exist for every single geography and updated very frequently, reducing administrative costs, external counsel, the need for a policy team at a solar company, and improving the speed, which results in lower electricity prices for end consumers and a faster deployment of distributed generation assets to accelerate grid decarbonization. Thank you so much for watching. We are so excited about this project, and we hope to remain in touch with the OpenAI team and everyone else that we met along the way during this hackathon.